Dream to become the next Sir Isaac Newton or Albert Einstein? Learn from the master. Refat Bari. Watch his videos to achieve your dream.
Go ahead and move on to the next question, okay? So let me just finish writing this one. Okay, so the dimensions of B are something comma something. Next question is perhaps even more nicer, and it is as follows. If I have two matrices, yeah, if I have two matrices A and B, if once again A, B, and BA are defined, then they're both squares, right? So if AB, if there exists a matrix AB and there exists a matrix BA, then A and, oh gosh, the dimensions of AB and the dimensions of BA are something, comma something. And that will be up to you to figure it out. And the final question, and perhaps the most exciting, is as follows. If I have two matrices A and B, and AB, their product, is equal to B, then A equals blank, okay? So it's up to you to decipher what A is. Now, the first thing we're gonna do is go ahead and tackle the first question. What is the first question? Does someone want to read the first question?
I can't see it from this angle.
If
A squared exists, if vector A squared exists, then the dimensions of A is clear.
Okay, so if there exists a square of a matrix, then what is the dimension of that matrix? That's basically all I'm asking. So do we have any ideas to tackle this question? No? No ideas? Alex, any ideas?
No.
Well, okay. So whenever you don't know how to tackle a matrix question, the best thing to do is come up with an example. Come up with a matrix. Okay? So that's exactly what I'm going to do. Would be great if we had another card.
But it exists for every matrix.
No, but let me show you. Let's say I have a matrix A. Okay? And let's say that matrix has dimensions m by n. Okay? So that means m rows and n columns. Okay? If A squared exists, that must mean what? That must mean what? That must mean A squared is equal to A times A, right? We covered this in the last few lectures, right? The square of a matrix is simply its product with itself, right? But that means I would be able to multiply a matrix of order m by n times a matrix of order m by n.
But that doesn't work out.
Right, unless n and m are equal to each other. You see? Unless n equals m. And in the case that n equals m, what we're going to have is a square matrix, right? Aren't we going to have a square matrix? Look, then we're going to have A is just m by m, and m by m times m by m is just m by m, which is compatible, right?
Or n by n.
So, can you finish this sentence now? If there exists a square matrix, then the dimension of the original matrix is what? Just use a variable. mm, which means it's what kind of matrix?
A square.
Square. Is it rectangular?
No.
Okay. Is it square?
Yes.
Yes. Okay. So first question out of the way. So hopefully now you get that kind of matrix thinking in your brain. Next question. Let's see what our next question is. Okay. So if there exists, sorry, I shouldn't read it. Alex, you want to read it?
Yeah. If there exists A and B, there exists the product of AB, and there exists product of BA, dimension A and dimension B.
Okay. So any idea how we can tackle this question? Any idea? Okay. So
Are they equal?
AB is not equal to BA. Remember,
No,
matrix
are they
multiplication is not commutative,
Yeah.
and
I
A
just
is not equal to B.
Yeah.
Okay.
Oh, okay.
So how can we figure this out? As always, it's always good to start with a diagram, okay? So let's say I have two matrices, A and B, just like in the question. A, this is B, okay? Okay, so we don't know what the dimensions of A are, okay? So I'm going to assume that it's rectangular. Let's say it's M by N, okay? And what about matrix B? Let's say it's P by Q. Well, if I know that AB, the matrix AB exists, what must be true? What must be true? If the matrix AB exists and A is M by N and B is P by Q, then N is equal to P. N is equal to P. Do you see that? N is equal to P. But we're also told that BA exists. BA exists. So that means I can flip this. And if I flip this, what do I get? I get P by Q times M by N. And now what do I see? Q must equal M. Right? Okay? So now that...
But P must also equal N, or otherwise they don't obey
Right.
that it's a square.
Right, so now we're going to start replacing, okay? We know P is N, so why don't we just write N over here? And we know Q is M, so why don't we just write M over here?
And we know M and N are the same.
Now what do you notice? The dimensions of A and B are just flipped. A is N by M, B is M by N. Isn't that amazing? So that means if you have two matrices and you want to multiply them with each other and both orders exist, that means the dimensions of the matrices are just flipped. See, amazing, amazing. Okay, because of the sake of time, it seems like we're going to have to reduce one question, but let's get to this final question, which is very interesting.
It's the identity.
Okay, yes, good. And hopefully that's obvious to you folks out there, because yeah, if I just plug in the identity matrix here, I won't get the original matrix. So thank you for watching.
Subscribe to Bari Science Lab to fall in love with math and science, especially programming.